Hello, students of geometry. Welcome to 10.3 areas of circles and sectors. Let's dive right into the lesson. Make sure you're using those extra examples in your book as well if you're one of my students to help you complete your assignment. So the area of a circle, I think most of us know this already. The area of a circle is going to be pi r squared. I would like to show you a little bit as to why that is. Thinking back to the fact that everything goes back to the area of a rectangle. So if you took a circle, you don't need to draw this or I'll put this on your notes at all if you're one of my students, but just watch this. And you split it up into different parts, and we continue to split it up into equal parts more and more. And if I were to arrange these parts into a shape that looks something like this, and I continue to take, I've got eighths right here, but I could split it into sixteenths, 32nds, 64ths, and so on, and keep going with that. Eventually, if I've got eighths, it's going to look like this. If I've got sixteenths, it's going to be even smaller pieces. And it looks like I've got 8 there, and so on until eventually I get to something. If I continue this to infinity, I'm going to have something that looks like this with edges that you can't even perceive any curves anymore if it's extended, the idea extended to infinity. So what's the area of a parallelogram? Well, it's base times height. And as you would, I really should look at this a little differently than what I have. As you would get closer and closer to these little slivers of the pie, so to speak, being smaller and smaller and smaller, eventually they would just be essentially straight lines going straight down like this. So eventually this would turn into this. This would be your height and your base. So area is base times height, but how long would the base be? Well, if we look back at this, go around a circle, what's the circumference of a circle? It's 2 pi r. So then half of that circumference is going to be here. If you're looking at something like this here and here, maybe that's these 4 pieces. And then I would take, let's do this in orange, these 4 pieces would be up here, these slivers. So the orange sliver down here and the red sliver down there would be half of 2 pi r. So that means this would just be pi times r. And then what would the length of this be? Well, the height would be the same as if we took these slivers and made them as small as we possibly could, infinitely small little slivers of that circle. The height would be the same as the radius. So what happens if you multiply pi r times r? What do you get? You get the area, which is pi r squared. That is just base times height right up there. So that's a little background into where that formula comes from. I really want to do that with you as I go through these notes, show you where these formulas are coming from to make it easier to understand, or hopefully at least give you a better appreciation of why the formulas are what they are. Everything again comes back to that rectangle idea, being base times height. Also on this one, let's call this the radius. The area of a sector, I'm just looking at this gray shaded area. If I called this x degrees, this is like arc length that we did earlier. We took the portion of the circle out of 360 total degrees and we multiplied it for arc length times 2 pi r, the whole circumference. So for area, it would be times the area formula, so times pi r squared instead. So we're going to use these two formulas as we move our way through the notes here. So given the following information, find the missing parts. The radius is 40. What's the area? This one is meant to be a very straightforward problem. That's not my best looking 4. I like to make my 4s look different than my 9s. That looks a little better there. So as before, and as I will continue to say throughout this chapter and the volume chapter, area pi r squared, write the formula in general first and then fill in what you know. So this one we are trying to figure out the area. We know the radius is 40. Very straightforward problem here. Just plug in r as 40 and then multiply that out. So 40 squared is 1600, so you'd have 1600 pi for this one. That would be an exact answer. It would be in pi form. And centimeters squared would be your units. If you approximated this, plug that into a calculator, and I would pause the video right now if you don't have your calculator out. Take it out. Make sure you're following along with your calculator, and that if you type in these things in your calculator, you actually get the same approximation as what I do. So take a moment to do that, pause the video if need be, go get your calculator and then come back to it. But when I do this in a calculator, and I'm going to get in the habit of doing this here with you for a while, showing you the decimal approximation to 5 decimal places and then rounding that off from there. So that's what I got to 5 decimal places, round that off to 0.5 from there, and then centimeters squared. If I said round to the nearest tenth, that would be the answer. If I said round to the nearest hundredth, that's 2 decimal places, you'd say 0.55 because that next digit is 5 or higher. So this right here would be an exact answer, and this right here would be the approximate answer. Pi form, approximate form. On this one, area is 36 pi inches squared. So I'm just going to put that on the inside. We're looking for the diameter on this one. The formula is still the same though. Area is pi r squared. Let's plug in what we know and figure out what we don't. So we know this time the area is 36 pi. We're going to take that and plug it in for A right there. So 36 pi equals pi r squared. We don't know what r is yet. But at this point now we can divide by pi on both sides. That's one step closer to getting r by itself. So that would go away, and that goes away on that side as well. So the pi's all cancel, and you've got r squared left over on the right side. And then from there, you can take the square root of both sides to get what r is. Now notice the question doesn't ask for r, it asks for d. But once we know r, d, diameter, is easy to figure out. So the radius is that. If we multiply that by 2, then we will have the diameter as 12. So d equals 12. Units are included as inches squared for area. That means the diameter would be in inches instead. So from there, let's take a look at some sector areas instead, and then we'll be done with this lesson. So we've got the area of the shaded sector below. Let's use that formula now. So it's the portion of 360 that you have. It's the piece of the circle that you're looking at times what the whole area would be. So we're taking a fraction of the whole area essentially by doing this. So the area, x over 360 times pi r squared. Take what you know, plug it in to find what you don't. 105 is your x, it's your degree measure out of 360 that we care about. And then times pi r squared times pi times 10 squared. And so then you should be able to get this in pi form. I want you to practice that here and go through that with me here. If we took each one of these terms and divided it by 5, so I'm going to write that in orange here. I'm dividing top and the bottom, numerator and denominator, by 5. We'd end up with 21 over 72. And this would be 100 pi, so 100 pi down there. You could put this as a fraction, put it over 1. I'll do that in a following step. Now you may have noticed that these are both still divisible by 3, so I'm going to do that here as well. So if you do this in 2 steps, that's fine. If you reduce fractions in 2, 3, 4, whatever steps, that's fine. Try to find the biggest number you can, as that will make your work more efficient. So I could have divided by 15 is really what I'm trying to get at, all in one step, and gotten to this fraction 7 over 24. But if you do it in 2 steps, 3 steps, not a big deal. So we've got that times 100 pi. And now I'll put this over 1 here, and then we can multiply that together. And so that would give me 700 pi over 24. If you are good at cross-canceling, I'm not saying cross-multiplication. There's no equal sign in between these two fractions. But anything with this term or this piece could be reduced with the piece across from it diagonally. You could do that in one step if you wanted to. I chose to just multiply it straight across here, and now I'll reduce. So looking at this, I noticed that 4 went into both of those things. So if I divide top and bottom by 4, then I would have 175, and pi is still there. So 175 pi over 6, and then only 2, 3, and 6 go into 6. None of those numbers go into 175. So this would be an exact pi form and an improper fraction form answer. So this would be in inches squared. Plug that in to a calculator, and you'll have 91. I'm going to do 5 decimal places again just to continue that habit. You'll see really for the first time significantly in a long time in the next lesson why that's such a big deal. to make sure you're not rounding off too much too early. But for right now, that is what I'd have. To 5 decimal places, if I said to the nearest tenth, then you'd say 0.6 because this digit after the 6 is not 5 or higher. So you have this as an exact answer. This is an approximate answer. If on a test question, something like that, you were told that you can just round off, as long as you showed me this right here without the divided by 5, that would be fine. You show me the setup, then you could go right to your solution here, round it off to the nearest tenth. I'd be okay with that. If it says pi form though, you need to know how to do these intermediate steps to go from here down to here. So let's take a look at example 3 to wrap this up. If the circumference of the circle now below this circle here is 92 meters, find the area of the shaded sector. So they tell us what the circumference is. We should know that the circumference formula is either pi d or 2 pi r, since 2 radii make up 1 diameter. So you can, now I'm finding the area eventually, so I'm going to want the radius eventually. So I'm going to use the 2 pi r formula version for circumference, and then plug in what I know and figure out what I don't. So I know the circumference itself is 92. So I'm going to take that value, 92, and plug it in for C right there. So I'd have 92 equals 2 pi r. And then from there, you could divide both sides by 2. If you chose to divide by 2 pi all in one step, that'd be okay. You would just have to make sure you put the 2 pi in parentheses if you're going to use your calculator to do that. So this would be 46 equals, and this cancels, you'd have pi r, and then from there I'm going to divide by pi, and I'd get this. So it would, I think, be rare where you'd be asked to find an answer to a question like this in pi form. But I'm going to show you how that would be done just in case you had to do that. So I'm going to leave my answer just like that for now. Pi is here canceled. 46 divided by pi would be an exact form of this answer. So in this case, or in this problem, this is our x degrees. It's not 100 that we care about. It's the remainder after we subtract 100 from 360. We want this shaded area here. So now I'm going to take this, I'm going to plug this into my formula there. And let's see what happens here. So we've got pi times r squared. That's going to be 46. And I'm sorry, I'm missing something here. I'm going to put it after the fact. So this would be the area of a whole circle. But now I'm going to do that times what? Times the portion of the circle, that sector that I care about in this case. So I'm going to do times x over 360. I'm going to write it after pi r squared instead of before. Multiplication is commutative, so the order wouldn't matter in which we multiply. So that would be fine to write it that way. So I've got 46 over pi squared. That's going in for r. That's 46 over pi right there. So then times, and then here I'd want to do 360 minus 100 over 360, which is going to be 260. But show me that works somewhere. If it's not embedded right into the formula, at least off to the side on the picture, show me where 260 would come from. So from here, this I would need to see somewhere, and you could go right to a decimal approximation from there if you wanted to. If it said you can round to the nearest tenth. But if it didn't say that, or nearest hundredth, whatever, rounding, then we would need to go through this process instead. So if you square 46 over pi, you'd have 46 times 46 on the top, which is 2,116, and you'd have pi squared on the bottom, pi times pi. So I'm going to leave it just like that for now, and then this would become 260 over 360. And then from there, this is like a pi over 1. So one of these pi's on the top here, pi times 2116, that would cancel with one of the pi's on the bottom. So I'm going to do that in a cross cancellation fashion there. And I'd be left with 2116 over 1 times pi would be pi. And then this could reduce down. You could cross off the zeros, and then you could reduce 26 and 36 even farther. So that's essentially divided by 10 by crossing out the zeros. And then both of these from there could be divided by 2, it looks like. And you'd be left with, whoa, that is a bad looking divided by 2. Let me try that again. So divide by 2, that should be the 0 there, divide by 2, there we go. And we've got 13 over 18. And from there, we can multiply things together, or we could use that cross cancellation sort of process. It does look like from there, this number and this number would at least be divisible by 2. So if you did that, that would turn into a 9, and this would turn into 1,000. And boy, I'm drawing a blank here. 58, yeah. So 1,058. So you'd have 1,058 times 13 on the top, and that would come 13,754, and you'd have 9 times pi on the bottom, so over 9 pi. So all that said, that would be an exact form for this answer. This would be meters squared, because we're talking about area. And if we approximate this, this is where it's crucial that you do this in a calculator. Yes, PEMDAS is true. A common misconception about PEMDAS, though, is that multiplication is more important than division. So it's really like this is level 1, parentheses comes first. Level 2 is exponents. Level 3 is multiplication and division. 4 is addition and subtraction. So you just do multiplication and division in the order in which they appear. But anytime you have a fraction, it's like there's invisible parentheses around the numerator and the denominator. So we really have to think of it this way. It's 13,754 divided by 9 times pi first. That comes first. You don't want to divide by 9 and then multiply by pi, because then the pi would essentially be with the numerator. So we want to look at it this way. So if you type in 13,754 divided by 9 pi, include those parentheses when you're doing that in a calculator, we'd have 486, I can talk, 486.44824, which is approximately 486 point, the nearest tenth, let's say again, 0.4. So you'd have meters squared. This would be an approximated answer. This would be an exact answer. And again, if you didn't have to get the exact pi form answer, you could go right from here. You show me that setup, and then you can go right to your approximate answer. You can plug that all into a calculator. Just be very careful that you're putting parentheses in the right places if you're plugging that into a calculator. So from there, I think that wraps it up for us here. If you have any questions, if you're one of my students, send me an email. If you're just watching on YouTube, please feel free to comment, and I'll try to get back to you when I get a chance. Hope you have a great day, and I will see you for the next lesson.